Need the following students to report to the front lobby for their field trip: Jaden Crum, Hannah Curtis, Logan Frazier, Colin Leffler, Jeremiah Neal, Danny Purvis, Ethan Purvis, Tommy Sagely, Emily Thompson, Andrew White, Skylar Wilbanks, Jackson Watkins, and Tyler Butler.
All right, so rational expressions are fractions. So we're going to simplify some fractions, we're going to multiply some fractions, and we're going to divide some fractions. So everything we do is going to follow the same rules that you learned in elementary school about doing that with a fraction. The difference is we're going to have polynomials in those fractions instead of just numbers, okay? So all of those rules, like when you simplify, you look for a common factor between them and divide both sides of that. Same idea with polynomials involved or monomials or whatever you've got. So we're going to first simplify and state these things called excluded values. Excluded values, and a pretty easy thing. What it means is what numbers would cause you to have division by 0. Because remember, that's the only number we can't divide by, right? 0. So when we talk about excluded values, those are going to be the numbers that would make the denominator turn into a 0. So this is a lot of the same stuff that we've done, just put it into a fraction form. So let's start with something easy. 24 over 56. 24 over 56. Regular old fractions, got numbers in it. Okay? How do we simplify that? Both of them are divisible by what number? Is that the biggest one? No, there's a bigger number that goes into 24 that also goes into 56. 8 is a bigger number that goes into 24 that goes into 56. 8 would be what we would consider the greatest common factor that goes into both of those. Remember, when we're factoring, we think about greatest common factor. So this is what's happening. We never did this in a while as far as rewriting that problem. We didn't rewrite it as 8 times 3 over 8 times 7. But that's what we thought when we did the work. That was the thinking that was going on. Is we had 8s that went into 24. We had an 8 that went into 56. This is what we thought when we simplified that. What we would usually do is we'd just cross it out and change that to a 3 and that to a 7. That's how we did it in elementary school, or hopefully that's how we did it. What we're going to do today is we're going to factor these things, and when we factor it, we're rewriting it this way. The difference today is we're going to have x's and things in there. So there's going to be factors up there in the top and the bottom. And what's going to cancel out? The matching factors, right? 8's cancel out. There's our 3 over 7. That's the simplified form. Now, as far as excluded values, and I'm going to abbreviate that as EV, just because that's easy to. Excluded values, EVs. So if I say EVs, excluded values. Okay? Is there an X in the denominator? No. So there's no number that we could put in the place of X that would cause the denominator to turn into a 0. So this one has no excluded values. And that happens sometimes. I just put none for excluded values. Here's the simplified fraction or rational expression, same thing. Excluded values, what number could you put in the place of X in the bottom that would cause it to turn to a 0? This one doesn't even have an X in it, so it can't have any excluded values. Okay? What we're looking at here is, as we step up the ladder, 12x squared over 16x. When we look at this one, we want to look at, okay, well, this has an X in the denominator. So that tells me that it's going to have an EV. Okay, so if I go over here to EVs, I would set the denominator equal to 0 and solve it. So how do we solve that? Divide by 16. 0 divided by anything is 0. So that's an excluded value. To find your excluded values, if there's an x in the denominator, you set the denominator equal to 0 before you simplify. Okay? Excluded values happen before you simplify. That's important. Okay? Now, the next thing to do is go back to the fraction or the rational expression and think, okay, what about the numbers? I got a 12 and a 16. What's the biggest number that goes into both of those? 4. So I know 12 is 4 times 3, and 16 is 4 times 4, right? What does x squared mean? X times x. And then on the bottom, we got an x. Now, we cancel out 1 to 1 the matching pieces. So we got a 4 on the top. It's going to cancel out one of the 4s on the bottom because there's only one up top to cancel it out with. It's a 1-to-1 cancellation. This 4 cancels that 4. This one of these x's and this x cancel each other out. What's left? 3x over 4. Okay. Now, can you shortcut that a little bit? Do a lot of that in your head? Absolutely. I expect you to. Okay. Let's do another one kind of similar to that and see if we can shortcut a little bit. Let's say we had 21 x to the third over 42 x squared. Again, I'm going to find EVs before we simplify. Excluded values happen before we simplify. What do we do to get the excluded value? What do we do in example B? Set what equal to 0? Denominator. Whatever the denominator is, set it equal to 0. This one's just got 42x squared, so I'm just going to get x squared by itself. So I'm going to divide by 42. X squared is equal to 0. And then we take square root. Square root of 0, 0. Excluded value for this one, 0. Okay. Now, we look for a common factor between 21 and 42. 7 goes into both of them. Is that the biggest one? 21 is bigger, and it goes into both of them. So we're going to use 21. So how many times does 21 go into itself? How many times into 42? Twice. So we know we got something over 2. What about the x's? We got 3 x's up here and 2 down here. How do they cancel? 2 of them cancel. Where's the one that's left? On the top. We've simplified that rational expression, that fraction, out of that. You may have done a little bit of this in Algebra 1. You may not have. It depends on what year, who you had and where you got to before end of course test that spring. This would definitely be one of the last things that you would do in Algebra 1. All right, let's go to this. 3x, parentheses, x plus 4, over x plus 3, parentheses, x plus 4. Now, this is a little more Algebra 2, okay? But it's already factored for us, okay? It's a fraction. You got a rational expression. It's got stuff on top, stuff on the bottom. First thing we want to do is find our excluded values. How do we find our excluded values? Bottom equal to 0. So x plus 3 times x plus 4 equals 0. It's already factored. So what do I do with each of those factors? Set each of those equal to 0. Good job. So that's going to be x equals -3 and x equals -4. Those are my excluded values for this problem. Those are the things that would make this have division by 0. They don't do anything else. For right now, they're just excluded values. We're finding those. We're going to use those. When we go to do equations, they matter. You got to be able to do this part first. Okay? Now, This is already in factored form. Everything's already factored out. So we look for things that match. Whole factors that match. Whole factors are 3, x, and x plus 4 on the top. There's 3 factors there. The 3, the x, and the x plus 4. On the bottom, you've got a whole factor of x plus 3 and a whole factor of x plus 4. You've got to cancel out whole factors at a time, or if it's just a number, then you can cancel out the number that it goes into. So x plus 4 and x plus 4 match up. So they're going to cancel each other out, right? Just like on the top, the first examples, the 8 and 8 canceled out with the 24 and 56, right? Same idea. It's just a polynomial. This cancels this. This 3x, this x cannot cancel that x because this one is tied to the other 3 through addition. Things that are tied through addition and subtraction cannot be separated and canceled. Only things that are multiplied together. That's the idea of factors. Factors are things that are multiplied together. So x plus 3, as it's tied together, and you can't break it apart unless you factor it. That doesn't factor, does it? So we're done. That's it. It's just 3x over x plus 3. That's the simplified form. Hey. All right. So next thing, let's get one that's not factored yet. X squared minus 2x minus 15 over x squared minus 5x. All right. First thing we got to do before we simplify is get the excluded values. Okay? So I'm going to go over here on the side. What do I do to find the excluded values again? So the denominator equal to 0. So x squared minus 5x equals 0. Since we're simplifying rational expressions, I know that there's a lot of ways to solve x squared minus 5x. I could use quadratic formula. I could use factoring. Those are methods to do this. But because we're simplifying rational expressions, I want to use factoring because that's going to give me a shortcut on the next part, on the simplifying part, because I'm going to have to factor it anyway, right? So how do I factor x squared minus 5x? It's only got 2 terms, but before I even get to that part, what am I supposed to be looking for? Greatest common factor. That's the first thing I always look for factoring is greatest common factor. What do x squared and 5x have in common? X. So I factor out an x, and that leaves x minus 5. And then what do I do with each of those factors? Set them equal to 0. So this one, x equals 0 is an excluded value. X equals 5 is an excluded value. All right. Because I've already factored that, I can go right here and write that factored form in the denominator, because that's going to help me. Because I'm simplifying, so I got to factor anyway. So I took my factored form from where I found my excluded values, and I just used it here. No sense in redoing it. You already done it. Now, how do I factor the numerator? X method, because it's got 3 terms, right? Doesn't have a GCF, so I need something that multiplies to be negative 15 and adds to be negative 2. Negative 5, positive 3. Negative 5 times positive 3 is negative 15. Negative 5 plus 3 is negative 2. Perfect. Can I use the shortcut to get my factors? Why can I use the shortcut? No number in front of the first x squared. So my factors are x minus 5 and x plus 3. What cancels? That factor cancels that factor, leaving us x plus 3 on top and x on the bottom. little bit on the long side, but not extremely difficult yet. Well, you got to say that. You can't say they're all level 1, so you got to go to level 5 sometime. Let's do x squared plus 2x minus 15 over x squared minus 25. So here we got a rational expression. The first thing we want to do when we're simplifying is get the excluded values. So let's get those excluded values. Set what equal to 0? X squared minus 25. Good job. What method do I want to try to use? It's a difference of squares. Very good. It's got 2 terms. There's no GCF. It's got a minus sign in the middle, so I'm thinking difference of squares is x plus 5, x minus 5. So there's my factored form for the denominator. Okay, and set those equal to 0. Bless you. So x equals -5 and +5. Those are the numbers that would cause us to have division by 0 in that problem. Okay. So we got the factored form when we solve that, so we're going to use that to do our simplifying. So I'm going to go up here and just rewrite x plus 5, x minus 5. And then I'm going to factor the numerator. How would I factor that numerator? X method again, -15, and add to be +2 this time. +5 and -3. So that'd be x plus 5, x minus 3. Which factor cancels? X plus 5s cancel each other. So there's x minus 3 over x minus 5. We've simplified that rational expression by factoring and canceling matching factors. Seems like an easier problem, but over the last 11 years, I see this kind missed more than the others. What we do first? Excluded values. Okay, so we're taking 10x plus 30 equals 0. Now that one doesn't look like a factoring problem. So I can just go ahead and solve it, right? Yeah, that's okay. You can do that. We're probably going to have to factor it in some way, but we don't have to factor it to solve it. To get x, because it doesn't have an x squared in it. Divide by 10. -3 is what x is. Okay. And then, so that's our excluded value. The next thing we want to do is factor everything in the problem, top and bottom. So I didn't use factoring to solve for my EV, so I don't get that shortcut on this one. But I need to look at each of these problems and see if I can factor them, the top problems and the bottom problems. Okay, so first thing I should look for if I'm going to factor. Greatest common factor. What's the greatest common factor on the top? 20x. I'll pull a 20x out front and leave what in the parentheses? 2x plus 1. What does the denominator have as a GCF? 10. What's it leave in the parentheses? X plus 3. All right. Now, can I simplify any of those factors? 20 and 10 can simplify a little bit, right? What number goes into 20 that also goes into 10? 10. So 10 goes into itself one time and into 20 twice. So that's going to be 2x, parentheses, 2x plus 1, over x plus 3. Technically, there's a 1 in front of that x plus 3, but you don't have to write it there. If you wrote it there, it's not wrong. But you don't have to have it. And just leave it that way. Don't multiply it back out. It doesn't help you really to multiply it back out right now. When we start adding and it's subtracting, maybe it does, but you don't have to. Hey, they landed in order. Good job. All right. Let's up it a little bit here. X squared plus 6x plus 8 over x cubed plus 64. The little boy says, wah, 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 wah. Well, so let's look at excluded values. First thing. What do we set equals 0? Denominator, x cubed plus 64. Can that be factored? How? Yeah, it's a sum of cubes, right? What cubed is 64? 4 cubed. 4 times 4 is 16 times another 4 is 64. So it's 4 cubed. So what are the factors? Remember when we did the sum of cubes and the difference of cubes, there's a short piece and a long piece. What's the short piece? X plus 4. What's the long piece? Yeah, it's always the opposite on the long one. In the middle is always opposite. The short one has the same sign. The long one has the opposite. And then it's always plus on this end. All right, now what do I do with those? Set them equals 0. So x negative 4 is that one. When I said x squared minus 4x plus 16 equal to 0, will that factor? Anything multiplied to be 16 that adds to be negative 4. 8 and 2, that's 6 apart. That doesn't work. 4 and 4, that's 0 apart. 16 and 1, that's 15 apart. So there's nothing that works there. So that won't factor. So how do I solve it? Quadratic formula. X equals negative b plus or minus radical b squared minus 4ac. Divided by 2a. Thank you. All right. So we'll work that out. 4 plus or minus 4 squared is 16 minus 64 would be negative 48. And I've got a negative under the radical, so that means we're going to have what kind of answer here? Complex, that's right. Yeah, good. Complex. It's got an I. It's going to come out. What else is going to come out with that I? 4 plus or minus. If I break down 48, that's 8 and 6. 8 is 4 and 2, 2 and 2. 6 is 3 and 2. So that's we got 1, 2 pairs of 2s. So that's a 4i on the outside. A 3 left over because that's that 3 right there is the one that's left over in there. All divided by 2, and I can simplify that a little bit because they're all those numbers that are outside of the radical are divisible by 2. So that's going to be x equals 2 plus or minus 2i radical 3. Here's our excluded values. Not a fun one, but definitely a very good review problem for that. But the good news is we factored a sum of cubes. Because now we got to simplify. So we got x plus 4, x squared minus 4x plus 16. How does the numerator factor? Multiply to be 8, add to be 6. I'm doing the X method there. That's what I'm doing. 4 and 2. Can I use that shortcut? What cancels? Yeah, that's beautiful. So we got x plus 2 over x squared minus 4x plus 16. Bless you. Bless you. Tough one, yeah. The sum of cubes. Anytime there's a sum or a difference of cubes in there, it makes it tough because you get that long piece is never going to factor more. Because they just can't work that way. The sums of cubes just doesn't work that way. So you've got to be careful of that. All right. Ease into another one here. So we had 5x squared minus 10x minus 15 over 2x squared minus 2x minus 12.
Israel Monroe, report the offense, please. Israel Monroe.
We'll do first. EVs. Set the denominator equals 0. Two x squared minus 2x minus 12 equals 0. That looks like it might factor. So let's factor it. How does it factor? 2 is a GCF, good. Leaves you x squared minus x minus 6. What about x squared minus x minus 6? X method on that. Multiply b, negative 6. Add to be negative 1. Negative 3 and 2. So that means my factors are x minus 3, x plus 2, right? I can use that shortcut because there's nothing in front of that x squared on the purple line there. That's why I can use that shortcut. That shortcut's going to be handy. That's going to happen quite often with this stuff. So set those equal to 0. What about this 2 that's out in front? Does it give us an excluded value? Does 2 ever equal 0? It just goes away. X minus 3 equals 0. X plus 2 equals 0. So we get x equals 3. X equals negative 2. Those are our excluded values. Now, good news is we factored that. So we've got the factored form here in the green line for the denominator. So we don't have to do that again. So on the bottom, I've got 2 parentheses x minus 3 and x plus 2. That factored form that I already found when I solved that. Okay, so I'm saving myself a step by using factoring to solve those. Can you find excluded values by using quadratic formula? Yeah, we just did it on the previous problem. You can do that, but it doesn't help you simplify. So that's where the factoring to find your excluded values is a better option. Okay, now let's factor the top part. What happens first? Greatest common factor of 5. So I'm going to pull a 5 out. That leaves me x squared minus 2x minus 3. So I'm just doing that here because I know that's not finished. I'm going to put my fully factored form on the blue line there. So how does the x squared minus 2x minus 3 factor? Negative 3 and 1.
So that's going to be factors of 5, x minus 3, and x plus 1.
Okay. What cancels? X minus 3.
Nice and pretty. The 5's still there because 2 and 5 don't share anything other than 1, so we can't cancel those. The x plus 1 is still there. The 2 is still in the bottom, and the x plus 2 is still in the bottom. That's our simplified version of that. Okay. Lots of factoring going on today. Lots. Let's do one more simplifying, and then we'll move on to multiplying and dividing. 2x squared plus 10x over 3x squared plus 16x plus 5. And I'll give you a break. When we get to multiplying and dividing, we'll quit doing EVs. Give us a break on that. I think you got that. You know what to do to get them. Just practice and do it.